Welcome to Thresholds of Reality, the podcast where we explore unexplained and mysterious events, phenomena, and legends. Today, Kyle and I are delving deep into the Fermi Paradox and trying to figure out where is everyone? We'll also be looking at some strange space sounds and taking a look at some very interesting recent sounds from space. So strap in as we examine the edges of the unknown.
This is an exciting one.
Yeah, Kyle, it may come as a surprise to you, given the subject matter that we've tackled so far, but alien encounters are not all that common.
No.
Yeah, it seems like we get to look at UFOs and we see all these things, but generally speaking, our civilization doesn't have a lot of contact with extraterrestrial life. And a lot of people have been scratching their heads over that for a long, long time. What up, Mojo? Thank you for tuning in.
Yes.
Appreciate you chatting as well. In fact, back in 1950, there's a Italian scientist named Enrico Fermi. And he was sitting down with several other scientists. And he and his scientists were sitting down, and they kind of came up with this question. And it goes like this: the size and age of the universe incline us to believe that many technologically advanced civilizations must exist. It has to. Just given the fact that we exist, we cannot be alone in the universe. Given there's Murphy's Law that says anything that can happen will happen, right? And given infinite amount of time, it'll happen infinitely many times. So, given the size and age of the universe, many technologically advanced civilizations must exist. However, this belief seems logically inconsistent with our lack of observational evidence to support it. So they're trying to come up with the reason why there's this disconnect between what logically should be the case versus the lack of our evidence. And he says they came up with four possibilities. Either our assumptions are incorrect and technologically intelligent life is actually far rarer than we initially believe. Or two, our observations are incomplete and we just don't have the technology to be able to detect the signals that they're producing. Three, maybe our search methodologies are flawed, and wherever we're looking, there's nothing there, but they're just everywhere. Or four, it is the nature of every intelligent life form to destroy itself, which, given the things that we're witnessing now, seems far more likely than probably any of the others. Like, I can't believe the stuff I'm seeing now. It's just like, oh my gosh, wars, food shortages, and all this other stuff. And it shouldn't be the case, but perhaps it is the case that just technologically advanced civilizations, they never get past their caveman programming, and they just end up blowing each other to dust.
Well, on like Star Trek and stuff, it's very, besides who they encounter when they go to look at a planet, very rarely were any of those planets technology what they were actually going into space.
But there were also Klingons and Romulans.
I know, besides who they already encountered, but like I actually picture it like most planets are like Star Wars without the spaceships. Deserts, a lot of trading, a lot of you know what I mean? They're kind of, I guess, more like us. Not like they're not willing to. They're not going that extra step like we are.
All right. Well, let's pause a second and think about what it would take for something to be technologically advanced. And it requires them to have some sort of digits, as in extremities, fingers.
At least thumbs. You have to have an opposable thumb.
That they can manipulate matter, right? That they can manipulate things with. They have to have some means of doing that. Now, dolphins are quite intelligent, but they can't do that because all they got is flippers. Why? Because their species evolved to be ocean-going species, right?
The aliens and the Simpsons didn't have fingers.
They had tentacles, right? So what about an octopus? Could an octopus theoretically do it? Well, they grab stuff, sure, all the time, but can they mine? Are they able to create heat sufficient to smelt and to labor in metals and create all these things? You know, we evolved from tree climbing species. So if a planet doesn't have trees, then how can they evolve thumbs or fingers to climb those trees? And then how do they evolve the intelligence to repurpose their tree climbing digits to everything else that we do, right? So
we did ours so we can go like this.
Yeah, we're repurposed tree climbers. We've repurposed these utensils now to manipulating everything. So it's not that it can't happen, but I'm kind of the belief that it's just a far rarer incidence than we believe. Like it's easy for us to look around at ourselves and say, yeah, you know, there's so many people, but that doesn't necessarily mean everybody who's come up has come up in conditions that allow them fingers and thumbs. And that's kind of a big deal if you think about it. This is probably the most advanced biological implement that there is on this planet.
Right, you got to push start.
Yeah. Yeah, I mean, a lot of animals use their mouths and their snouts, but very few of them have the type of articulation or manipulative abilities with their fingers and thumbs to do anything.
I think most of the universe they didn't evolve from tree climbers, so that they don't have that ability to make it so they have maneuverable crafts that they could use.
Yeah, I think it's just a rare thing. Like did you know that sharks are older than trees? Sharks came first, and then trees evolved later.
What came first, the shark or the tree?
The sharks did by a lot. It's not even close. So maybe it's just the case that the conditions required for these are not very common. But that said, it's not like we haven't had any evidence. And today we're going to talk about some of those materials or some of the evidence that we have found.
Can you go over those 4 of those real quick again?
What was that?
Go over those 4.
The 4 things.
Yeah. So just do number 1 first. Don't rattle them off.
Okay. So the four things are either intelligent life is much rarer than we believe. That's the one I think. 2, we lack the technology to make the observations. 3, we have the technology. We just don't know what we're doing with it. We're using it wrong.
I think that's where I think we're at 2 and 3.
Okay. And then 4.
Technology, we're getting into technology, but I think we're looking at the wrong things.
4 is kind of like a time thing, right? If each civilization lasts about 6,500 years, for example, and we're pointing out into space and we're covering basically millions and billions of years into the past, it could be that we're just missing it because we're temporally so distant from each of these other civilizations that have ever existed that we'll never be able to find one that exists at the same time we do. So it is the nature of intelligent life to destroy itself. That's the fourth one. And maybe
that's a pretty good one too. That this is kind of bounces around from place to place, and as time moves on, and now this is our turn.
Yeah, and we're peering out into not just the distant space, but also the distant past, right? Because it takes light so long to travel to Earth, where we can observe it, that by the time it reaches us, we're actually looking at the distant past.
Which sometimes you think about that, and it's hard to wrap your head around that. That's God knows how long ago.
Yeah,
like because that you're looking at a light or something that probably might not even be there anymore.
Yeah, Mojo says, the crazy thing to me is how environmental factors influence evolution. Like if we didn't have trees like we do, what would humanity's first land-dwelling ancestors have evolved into? Well, you can see all the different options that there are, right? We have cats, we have dogs, we have birds, we have bats, we have shrews and underground mammals. We have all different kinds of things. So the things that it could have been have already proliferated on the earth, right? Anything that can happen will happen. So that's what we're looking at, is all the different possibilities. They exist with us at the same time. And so how does the environment influence those things? It influences it greatly. It's just whatever is able to reproduce and make it into the next generation, that proliferates. And
I'm sure
you get more.
It's going to be hard too, just to get, like Earth is the exact distance it needs to be away to, you know what I mean, to not burn up or. Go ahead.
Well, so it's good that you bring that up. There's an estimate that in this galaxy alone, there's something like 3 million sun-sized stars. And of those 3 million, you would assume that there's a certain percentage, maybe 10%, right? We have 8 or 9 planets in our own solar system. And out of those 8 or 9, one of them is an habitable zone. So we're looking at what? 1/10 of 3 million. What is that? 300,000? So it's 300,000 Earth-like planets, possibly, in our galaxy. So that's kind of the easy part. But the question is, what are the conditions of life? I mean, they may have water. They may have dry land. They may have a lot of things, but a lot of the building blocks of life, the so-called building blocks of life required, come from space. Amino acid building blocks, the foundations of proteins and DNA, they often come to here from space. Mojo says, true, but all those things evolved in a way that has been influenced by the human presence. Like if we weren't here, did our dogs and cats wouldn't be what they are. True, but also their ancient ancestors are still around as well, right? We have lynxes and bobcats and wolves. So yeah, cats and dogs are the domesticated version of those. And the particular trait that they were evolved from is domesticity, their ability to get along with humans, which is interesting to me. But I think that's kind of beside the point. I think what I'm trying to say is there's a lot of different variables, and I think Kyle, you're nailing it, which is how often do these things occur in nature?
It just seems like how there has to be so many exact things that have to line up for life on a planet to be able to sustain.
Yeah, you're right.
It seems like almost like the chances of winning the lottery or something, like probably even more, probably higher. But I'm just giving it a number that is reasonably easy to think about.
You're 100% right. But think about how many times the lottery gets played, how many tickets are bought. All right, so your odds are 1 in like 6 million or something like that. But how many tickets get bought?
Lots of people buy lines and lines and lines of tickets.
Yeah, tons. And maybe I think it's 60 million. Sorry, I said 6 million, but it's 60 million. So if you have 1 in 60 million chance of winning, each individual ticket has a 0% chance of winning. But across the field of purchases, there is a 100% chance that at least one ticket wins, right? So if you're looking at the law of large numbers, yeah, even though each individual ticket has a 0% chance of winning, if you take the whole field together, one of them has a chance of winning. So there's a 100% chance that someone in the field is going to win. And that's kind of the way it is with when we're looking at space and with stars and planets and stuff, is that, yeah, these individual circumstances have a 0% chance of existing. But because we're running such high numbers, across the field, there's a 100% chance that it happens.
Bojo's got a good point. Because there are a lot of different variables. These factors are bound by our current perspective. There could be a place where life isn't carbon-based, and that would change all the susceptibility of standards.
Yeah, that's absolutely a possibility. And I think our assumptions are that the things that we have discovered and that we use to communicate are common amongst all of the possible ways that we can communicate.
Because it's the only way we know.
Yeah, but it's just what we are aware of. And so as soon as we figured it out, we were like, hey, let's show off to the universe that we figured out radio signals and that we figured out
the door's moving.
Yeah. Come on out. You gonna come?
But yeah, that's just, and when we have these theories, we are basing on, because that's the only thing that we know.
All right. Yeah, you're right. We have a limited perspective, but I think everything that we use in that perspective, we're shooting out into space to see who else is picking it up. And I think the Fermi Paradox, I think they've really hit on something, which is one of those or all of those are true, which is, it's possible that life is rare. It's possible that our technology is limited. It's possible that space is so vast that even though we know what to do, there's just no way we can get it all. There's no way that we can cover all the night sky. And it is also possible that these civilizations are short-lived, and so we'll never kind of cross paths with them. But that said, there are some interesting signals that I want us to take a look at. And I wanted to start with one that came in 1977 called the WOW signal. I'm going to play a bit of it here. And so that's what we call the WOW signal, or what is called the WOW signal. And it was discovered in Ohio at like a college lab that had been running a SETI project. You guys, are you familiar with SETI? SETI, Search for Extraterrestrial Intelligence. And they have various projects going on around the world at any given time. But one of them was this like peering into space at various constellations and searching for radio signals. And one night in 1977, there was a guy who was just kind of monitoring the radio reception equipment. And he gets this report, and it shows this very intense signal. They were running each section in like 72-second bursts. And he said, what you would expect from intelligent signal, a signal originating from intelligent life, is that it would last the entire 72-second burst. It would grow in intensity to the halfway point, and then it would dissipate. And that's exactly what this signal did. As soon as they pointed in that direction, it began, and it went up, and it peaked at like 36 seconds, and then it kind of came back down. And the guy who found it, like, he pulls it off the printout, and he writes "wow" with an exclamation point next to it, and that's how it got its name, wow signal. And then he gives it to his colleagues to examine, and they said, we got to go back there and point and see if we can find it again. They never found it again. They spent like 50 tries trying to locate the exact spot where that signal came from. They were never able to find it again. So left everyone kind of scratching their heads and with like an empty feeling in their stomachs that they had found something great, but then it turned out to be nothing because they couldn't reproduce it. When you heard that signal, what did you think?
It just sounds like, but since I can only relate it to here, it just sounds like some kind of high-pitched whining type of thing.
Yeah, like a whistle, right? Like
yeah. Because I know the Earth makes kind of that kind of noise as well. It's let me see if I can find it and play it for you guys.
Yeah,
it's called the Earth whistle.
Earth whistle.
So let me share my screen. Hopefully you guys could hear it. So this is and that's plasma. Can you hear it?
Yeah.
That's plasma waves interacting with our magnetic fields.
Sounds like birds.
Almost, right?
Oh, that's crazy.
Yeah, so
sounds like the Silverhawks or something, like an 80s cartoon.
Yeah. Well, I thought that was cool. And, and I don't know if we should get into it, but why it's crazy that we find signals and, we have to take how we find a lot of these signals and actually make them into sound because there is no sound in space. Because there isn't enough atoms in space for sound to travel. That's why no one can hear you scream.
Space, no one can hear you scream. What was that? That was from Alien, right?
Yeah.
Yeah, that is true for like the vacuum of space, but not everywhere in space is a vacuum. There are like gas clouds and galactic superclusters that do have a lot of kind of dust and gas in that fills that kind of space. But yeah, it is true for the vacuum of space where there's no matter, there's no air molecules. It's really tough for that kind of thing to transmit.
But let me see. And I think a lot of these things that I found that are noises, that's what it is. It's like it's as you're getting closer to where there's stuff clustered together, you're finding that the noises that it's making.
Dude, that actually kind of the Earth whistle was kind of cute. I don't know about you, how you feel about it, but I thought it was like, whoop, 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 whoop.
That's why there's so many aliens that come here and abduct us, because that's what they hear, and they're like, man, it sounds like a...
Hey, they sound like they're down for a good time.
Yeah.
Are they checking me out? Do they think I look good?
But there was another cool one that it's Voyager, as it was crossing in interstellar space, it sent back something that a noise that they got.
Gotta hear this.
So this.
This is where it crosses.
And that's what I expect space to sound like.
Just a whistle. Yeah, there's so much happening in space that we're protected from because of the sun, because of Jupiter, because of our own magnetosphere. There's these like the auras of these heavenly bodies is protecting the Earth from all of these things.
This is here they played. This is what Jupiter sounds like. And this is what
I think Earth is cuter.
It is. It's the best. This is where you could hear. So at the top, there's a huge storm going on.
Yeah.
And this is what it is. And as it gets
this is like their northern lights.
Yeah. And then you'll start.
Wow. Sounds like a thunderstorm.
Yeah. So I thought that was cool. And then there's as you're crossing Saturn's rings. And it's hitting the dust particles in the rings.
Right. A lot of dust and ice.
Sounds like someone's cooking something. Actually, it almost sounds like rain. Like rain hitting like a microphone or something.
It's pretty chill. I'm digging it.
So I thought those are actually...
So these are actually reasons why the folks at SETI were kind of skeptical of the WOW signal, is because they're like, well, look, it may be the case that we're just bouncing our own signals back to us off of these other heavenly bodies. And I'm not talking about you, Kyle. When I say heavenly bodies, I'm not talking about you. I'm talking about Jupiter and then the sun and that kind of thing.
That's what happened. That's what's happened a few times. Like there was those Russians, they thought they had found a noise from space, and it ended up being, it was bouncing off their own satellite.
Oh, yeah.
The noise that they were getting was actually the noise of bouncing from their own satellite. So they're getting the noise of their own satellite back at them.
Yeah, exactly. But the search for extraterrestrial intelligence has kind of evolved beyond just these radio signals. They also use visual spectrum light, where they just have these arrays of telescopes, essentially telescopes, radio telescopes, pointed out into different sections of space at a time. So they're like, so we're just going to look at this little corner of space, and then tomorrow we'll just move to the next one just a little bit over, and then the next one a little bit over, and they just do that. And they're just trying to cover the entire night sky. You know, it's hard to say 360 because it's 360 times 360 times 360, right? We have three dimensions, or maybe 360 times 360. So you have this circle times this circle, and it gives you a sphere. And they're trying to cover every little, square of that sphere. and see what they can find. And
Oh,
they've
cool.
also now,
You could find something or not find something, and you still get to work. It's job
yeah,
security.
that's right. It's like Weatherman, but even better.
Yeah.
And but they've kind of automated the process, so it's really it doesn't take a lot of people to manage it. Just takes a few, and they just keep pointing it. But there's hundreds of millions of dollars that are poured into these research projects, and they don't find anything. 1977 was like the last big thing that they found was this wow signal.
Was it I think it was there that there. I know there's that big one that happened in 2019. Remember where they were getting something? The bursts were occurring in patterns every 16.35 days.
Oh, do you have that one?
That is, and what they actually figured out what this one was.
What was it?
But it was
quite bright, but they only last for.
Damn it! So what it is, they're saying it's small bursts in space. These
like star emissions.
Like they say, there's these little millisecond bursts, and that they're rippling out, and that's what we were catching.
Yeah, there's lots of different emissions in space. You can have quasars.
Better start testing them.
And magnetars and gravity waves, and they've started looking through all of those types of things to try and find if there's anything there as far as intelligence. But one of the things I thought was really interesting is they have quantum. They're looking for quantum signals, which is like, that's kind of the cutting edge of what we're at. So in a 2021 preprint, an astronomer described for the first time how they could search for quantum communication transmissions sent by extraterrestrial intelligence using existing telescope and receiver technology. He argued that future searches for SETI should also target interstellar quantum communication networks. And so it's really fascinating, all the different things they've got. They've got what they call Techno Signatures, which I think is an interesting one. They're looking for Techno Signatures may originate from various sources, such as Dyson spheres, space mirrors, or space shaders. Or they've also got some that are from, harvesters of stellar material, asteroids and comets and things like that. But have you ever heard of a Dyson sphere, Kyle?
Space shader.
So a Dyson sphere, for anybody not familiar, is a giant vacuum. Cleans your house very well. Just kidding. No, Dyson sphere is an interplanetary object. Think of it as someone building a solar panel all the way around a star. A giant sphere of solar panels built all the way around a star for the purpose of capturing 100% of that star's energy and then converting it into whatever they need it to convert it to.
Wait, so what?
Okay. So imagine we had unlimited resources, unlimited electrical lines and unlimited solar panels. And we could construct in space a sphere around the sun big enough to capture 100% of the energy that it releases. That's a Dyson sphere.
Oh, dang.
Yeah.
And what do they do with that?
They use it to power their civilization.
Dang.
So they would use it as like solar panels like we do to convert light into electricity. They'd use the heat to heat their water or
greedy if you
whatever.
ask me, though.
What's that?
It's pretty greedy if you ask me.
Well,
You
what
cover
are
a
the
whole
other
sun
things
up with solar panels. It's not
Yeah,
fair
who,
to
to who?
It's not fair to the rest of the planets.
What does Jupiter need with the solar radiation?
I'm sure something. It's just not fair. It's just not fair. I'm just sticking up for the planets.
Yeah.
Somebody has to.
So Halo is like a partial Dyson Sphere. Have you ever played Halo? So the Halo in Halo is an artificial planet. It's basically a ring that they've constructed around a star that they can live on. And it's basically the idea of a Dyson Sphere, but just one ring instead of.
Fair.
Yeah, they're being fair. They're not trying to take everything, just a strip.
Yeah, I'm good with that.
Interstellar Ethics with Kyle Stinson of Threshold to
But
Reality.
I mean, like, if you were to block everything, like that wouldn't that mess up all kinds of stuff? Gravitational pulls, the way the sun keeps everything kind of in place, and
Well, so gravity it would be unaffected, other than the gravity kind of holding that Dyson Sphere at a distance. That's to me, that's the thing that I would be concerned about is how do you keep those panels from being pulled in by the star's gravity. But as for everything else, like the gravity, it would absorb all the radiation, so you wouldn't have things like northern lights. You wouldn't have things like wind on the other planets. They'd turn cold.
solar flares.
Solar flares would be contained. Yeah. So that's the idea. That's one of the things that they're looking for is a Dyson Sphere. And not that they're just theoretical objects. Like we have no idea that they exist or that they could exist. It's just that's a theoretical thing that if your planet or your civilization were highly advanced, it would need an intense amount of energy. And one of the ways you could obtain that kind of energy is to just capture all the energy from a local star.
So they're trying to see if somebody's already done that.
Right. But that in itself presents difficulties in detection because how do you look for a hidden star? You'd be looking for like an infrared signature, but there's tons of objects in space that give off infrared signatures. So, it's just you're guessing at what you're looking at.
Another good job to have. I'm looking for something that might be invisible. How's that going? I'm still looking.
It's really tough.
Still looking. You haven't found that hidden star yet? Nope, still looking. All right, Jim, we'll get back to you in a few months.
We'll let you get back to it. It sounds like you got your hands full. I'm looking for my contact. Do you have a contact? I don't remember. Maybe.
I think that's how do we get into that?
Yeah. That's a tough one. Like you're looking for something that's theoretical 100%. But one of the things that scientists have done recently is they have kind of turned their attention to black holes. And that we here at Thresholds of Reality have an affinity for black holes. That's kind of our logo, is that black hole in the Phoenix sky. And they kind of turned the signals emanating from a black hole into music. And this is one of the things that we wanted to talk about. So I'm going to play, there's two versions of it. One of them is based on the signals radially, meaning they're translating the signals as it's emanating from the center of the black hole out, and then it's just kind of panning 360 around the black hole. The other one is more of a linear thing, and they've set up three parallel versions of the signal, and they kind of harmonized it. So we'll listen to both of those.
So I'll tell you exactly what the second noise is when they're trying to sell you the timeshare of going to the black hole. The first one is exactly what the black hole sounds like when you get there.
Yeah, that's right. That's
But
what
the
the
first
HOA
one-
doesn't want you to know. This is what your neighbors sound like. But we'll sell you. This is the pamphlet. Yeah.
But the first one is kind of like the one that I did from, once that satellite hit, the further space, the creepy noise. That's what you expect space to sound like.
Right.
So, like that black hole is the one that they got from the one that we found a while ago, and
No,
that we've been looking at, or is that the newer one that we found?
So both of those sounds that we just heard came from the same place, and they were both earlier this week on the 12th, and they're just different interpretations of the same data. So if you play it radially, that's the first sound. If you play it horizontally or linearly, that's the second sound.
So that was from the black hole that we found on May 12th.
Yeah.
And that one's actually relatively closer than the other one that they found.
Oh, no. Okay, so this is, if you're talking about the image of the black hole at the center of our galaxy, that's different than what we just listened to. That's not what we were listening to. We're listening to what they consider the sound of a black hole. But it's just an interpretation of radio signals that they're getting from these places.
But the one they found on May 12th, that's not the one they were talking about a while back.
Okay, so when you're talking
about the black hole itself.
Yeah, so the pictures, right? You got it on your screen, it looks like. You want to share that so we can take a look? Yeah, so this is the supermassive black hole at the center of our own galaxy that we're looking at here.
Mm-hmm.
And then if you click over on those pictures up above, that one right there, yep. That was the image of the black hole that they presented, I think, back in 2019 of a nearby black hole. And the light up parts that you're seeing are what they call the accretion disk of the black hole. So if we look at our own logo, if you want to take the screen share down. So what we're looking at in our logo there, that kind of horizontal stripe across the middle, that's what they call the accretion disk. And it's like Saturn's rings. It just goes all the way around in a disc shape. But because the gravity is so strong, the light from behind the black hole gets pulled up over the top and then is pointing out towards us. So we see the back of the accretion disk. At the same time, the light coming from the bottom of that accretion disk gets pulled forward from the underneath and is also visible. So what we're seeing is the back of that accretion disk, but the gravity is so strong that it's bending the light, like it's refracting the light around the black hole itself and then pointing it towards us, which is pretty cool.
It's crazy to think.
Yeah.
I wish there was one closer, like right behind Mars. Just a little one, though.
Yeah. I feel like that was headed towards a Yo Mom joke.
No, was it?
I wish there was a closer, like your mom. And your mom's a black hole.
I just think that's cool that we've actually found two.
Yeah, so the reason why we pointed our instruments at that first one from 2019 is because there's a lot of visual obstacles from where we're at to where the center of our galaxy is. So if you go out and you look at the Milky Way, let's say you're camping up in Happy Jack or something, and you're looking in the night sky and you see the Milky Way. And the reason why it's not blindingly bright is because of all the dust and the gas, that the stellar clouds that kind of exist that block and absorb a lot of the light coming from all the other stars in the galaxy. And though that same dust and gas and debris, it's an obstacle for our telescopes in space as well. And so it took them a lot longer to process the data from our own Milky Way black hole than it did from your mom's black hole.
Because there's so much in the way.
Right. But yeah, that's what we're looking at. So if you want to pull your screen back up. So that is a more distant black hole. And then there's a picture of them right next to each other. Yeah. So the one on the left is the distant galaxy, or the distant black hole. The one on the right is the supermassive black hole at the center of our own galaxy.
That's crazy. When did they just found it?
It's not that they found it. It's that they finally were able to compile the image. It's incredible how much data and processing power is required to just make these very blurry images of these black holes.
Using an old Nokia flip phone to take these pictures.
Yeah, they're going to start playing Snake, and it's going to gobble them up. Yeah. Yeah, it's incredible the amount of processing power goes into just creating these images, as crappy as they may be. But then they use these images to confirm the artist rendering, like we see from, like the image that we have. I think they made that, or they calculated that and used it in the movie Interstellar, and we've kind of cribbed it and put it in our logo. But that's
it says oh yeah, right here. It's blocked by a lot of dust in our own galaxy, making it difficult to see through all the material. This scatters the radio waves and blurs the image. But years of observations at wavelengths have made it possible for astronomers to partially mitigate the effects of the blurring.
Yeah.
So we need to figure out a camera that could go get through the dust.
Yeah, and what they do is they use different signal wavelengths to find a way to get through it, and basically eliminate it's like the magic eraser on an iPhone. You know, you have somebody in the picture you don't want in the picture, you have to go on and do a magic eraser on them, and then the AI in the photograph editing software guesses what's behind them, and then kind of superimposes that guess on top of whatever actually was in the image.
It's like watching McClay make a thumbnail for us, and he's sitting there and eating everything around the image that he wants to use.
Yeah, exactly. So they had to use a lot of interpolation and extrapolation to figure out what the image actually was. And you notice they do have a little bit of a different shape. So it's like there's 3 nodes on the supermassive black hole in our galaxy, and then that may mean that we're not looking at it straight on. And then the other one looks like what you would expect, which is like a kind of a spherical thing with the light being pulled over the top and underneath towards us.
Oh, so you think our black hole, we're seeing it from the side?
Yeah, it might be kind of skewed a bit, but like it looks like there's 3 nodes on the accretion disk there, and that may be that there's just like stars being gobbled up nearby. I don't know. Whereas the other one looks more like what you would expect, and more like what they showed in the Interstellar movie.
That's crazy.
Yeah.
I think that's super cool. I can't wait to hear what that one sounds like.
Right. Yeah, I'm very excited for all of these developments in astronomy and the heavenly bodies. The new James Webb telescope is going to be bringing us a lot of really cool images from space. It's got really clean stuff. It's scanning a lot of different frequencies and wavelengths. But all of it kind of back to our original topic, which is the Fermi Paradox. It doesn't guarantee that there's life out there. Maybe we're it. And maybe our quest to find something else is ultimately fruitless, and maybe even worse, maybe it's actually hurting us by creating pollution or nuclear war or whatever, nuclear fallout, and who knows. But the Fermi Paradox persists, which is ultimately summed up with one question: where is everybody?
I think they're like my neighbors. When they first moved in, they just act like we weren't there. We came outside to introduce ourselves. They just turn their back and act like we weren't there. I think that's kind of what extraterrestrials doing to us. No, I honestly think, and I've said it before on other shows, I honestly think that it's just too far away. Everybody's too far away, and I don't think any, except for the aliens that abducted me last night before MCM, I don't think any other. I think it's just too far to make the trip, and I like we've talked about, it's a chance that aliens have learned how to bend time so that they can get somewhere, and I just think it's just too, since the odds are so small of supporting life at somewhere, it's just too spread out.
I recently started reading a manga. Yeah, for everybody who doesn't know, I'm a big time into anime manga stuff, but recently started reading a manga, and they had their own hypothesis, and I thought you might enjoy this one, Kyle. But it was that the ghosts and other supernatural elements that are native to Earth are keeping the aliens at bay, because they don't want to get into any altercations with the supernatural forces that are native to Earth. And I was like, oh, that's interesting. Maybe Kyle's ghosts are fending off all the aliens. And
they didn't fend off the dude that I caught on my camera walking out of my backyard on Friday.
What?
My Ring camera went off when I was at work, and some dude came walking out of my backyard and walked off.
Did he steal anything?
No.
He's just trespassing.
I called the police.
Crazy.
Yeah. I think that was the alien that abducted me.
Well, for whatever reason, in a certain sense, I'm glad that we don't have other alien extraterrestrial life forms to tangle with. I'm not sure that they're going to be, I think they'll be hostile. I don't think they'll be kind. I don't think they'll be.
You think they're going to travel all this way, like Will Smith said in Independence Day? They're going to travel all this way to start a fight. That's assume because they've figured out, hey, this planet is got X, Y, and Z. Because eventually we're going to get to the point where we're going to be like, okay, we need to find somewhere to take over because of X, Y, and Z. Because of what we're doing here, eventually, you know what I mean? They're going to have to figure out we're going to have to go somewhere else.
Yeah, I would assume that, like we are with other animals, they would probably look at us as though, maybe whatever it is that we feel or experience as pain or sadness or loss, they would not recognize that as intelligent life.
I figure they're going to be like, they got this cool looking planet that makes this nice bird whistle, and they're just destroying it.
Dude, you got to put that back up. Do you still have that?
Yeah.
But yeah, I would say that there's probably going to be some measure of colonization, some measure of despoiling of the planet, and trying to extract its resources.
Yeah, I'll bring it back up for everybody.
But yeah, this would be a great way to close.
I just say if I just got done spending time and this is the noise that was getting picked up, I'd be like, I'm down with that.
Yeah, it's like you're out in the bayou listening to the frogs and the birds all sing to each other. Then the G.I. Joe shows up. Beep, 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 beep.
I mean, it shows that we're a place to come and hang out. Plasma waves
I love it.
against our
This is so
magnetic
cool.
fields. That's what I expect when we figure out how to teleport.
Those are cool sound effects, man.
So
Well, what are your final thoughts?
if we go back to your original, the Fermi Paradox, I still think we're somewhere in between 2 and 3.
Yeah.
Those are where we're hitting.
Yeah, the first one is, so 2 is technology is limited and 3 is space is vast.
And I think that's where we're at. Our technology is limited right now of what we could do and see. And I think the other one is space, is because space is so vast, we don't have the technology to do it.
Yeah.
But I mean, you got to think the technology from, what we sent out for Voyager 1 is a heck of a lot better now than that,
It's true.
I just, that, was it Voyager 1 where they sent out that plaque with it?
Yeah.
It had like
It's like a naked man and woman and then some simple messages. Yeah.
a couple of math equations, I think, are on it.
Yeah. E equals MC squared.
So, but I mean, I mean, you got to think, when did we send that off?
Oh, decades ago, I'm sure.
44 years.
Yeah.
So can you imagine another 44 years of, 44 years ago, we weren't landing rovers on Mars. I mean, vast space, I think we're going to have to, it's going to take something.
Yeah. In the grand scheme, we've covered very little time at all.
Yes.
Yeah. I think all 4 of those things are probably pretty likely, but the one that kind of sticks with me, or the one that I like, is what we are and what we can become is actually quite rare. And it may be that we are the only intelligent life occupying the universe at this particular moment. Certainly in our galaxy.
Bummer for the fucking universe.
Well, the universe is indifferent. They don't care. The universe doesn't care.
Space doesn't care.
Space doesn't care.
Right now is our time.
That's right. Make the most of it. Well,
and on that note, make the most of it.
Yeah. Keep on exploring the edges of the unknown.